Hello viewers, welcome back to Dexter's Tech Lab. Sorry it's been so long since I last made a video. There's been a lot going on and I just haven't had time and the opportunity to make anything. So my apologies, but here we are to correct that with another Quantel video. So I want to thank all of my loyal patrons for supporting me, even though I've not really been making many videos recently, but thank you very, very much for sticking around. Hopefully this is going to change and I'll be able to start making more and more videos, hopefully. I also want to thank PCBWay. This episode of Dexter's Tech Lab has been sponsored by PCBWay, your one-stop solution for PCB prototyping, PCB assembly, and this is not just normal PCBs. You can do flex, flex rigid, all this sort of stuff. They also offer 3D printing, CNC machining and milling, sheet metal fabrication and injection moulding. So tons and tons of options there for turning your current project into reality. So obviously you're probably pretty aware of how big the Quantel collecting community has become. You've only got to visit my Discord to realise how many people there are now, sort of actively going out there, talking to people who used to use these machines, trying to find old machines, trying to restore them and all this sort of stuff. Now because of that, Adrian Wilson, who has been a big supporter of the channel, and he has also 2 paint boxes himself, he found this machine in London and it had been stored in somebody's garage, and they wanted to move it on, so it was bought from him and then brought up to me to have a look at, because we don't really know its condition. We believe it was turned on about 10 years ago and I believe it was working then, but you know, a lot happens in 10 years. So the plan for this is to just evaluate its condition at the moment. I mean, obviously this has been stored in somebody's garage for 10 years. It's seen a little bit of damp and maybe a little bit of water and a lot of dust. So it's going to be a bit of a careful one to sort of go through and check everything stage by stage, just like I did with the HAL, if you remember that one, and see what condition this is in. Right, you're probably asking, what Quantel is it? Well, this is a Quantel Editbox. The Editbox was one of 2 top systems from Quantel back in the early middle 90s and onwards. This machine actually dates from 2001, I think. So these were being made for quite a long time. But yeah, the original design goes back to the early 1990s. So the 2 top systems from Quantel were the Editbox and the Henry. The Henry was the top of the line system. The Editbox slightly less so, but they were kind of orientated for doing different things. The Henry was more of a big effects compositing machine, whereas this was more inclined to do editing. The interesting thing about this is a Quantel Editbox and a Henry, hardware-wise, are the same. So it's literally just down to the software that runs on it and the license keys. Technically, this isn't Quantel's top-of-the-line system. It's not a Henry, but it is, because it's just the same. It's the same bit of hardware. So the Editbox, as I said, can do video editing. Now, just like the HAL, it's all done on full broadcast quality video, uncompressed. The important thing that makes this different from a HAL is the speed that this works at. And that is marked by its price. So I believe a Quantel HAL was probably 150,000 quid. That's sort of an educated guess, let's say, but I would say somewhere around that, whereas the Editbox was about $250,000. The Henry was probably another $250,000 on top of that, so you're probably looking at about $500,000 for one of those. So why does this cost twice as much as a Quantel HAL? The reason is the speed, as I said. So HAL works on, it's a very single pipeline machine. If you want to create a video effect, let's say you wanted to composite one image on top of another while moving it about, doing a DVE move. What happens in HAL is the video frame is loaded off disk. It's then rotated as a step, filtered as a step, sized as a step, and all these steps take time to process. One happens after the other. So it's effectively a single pipeline machine, which slows things down. Now, the only way you can make this quicker is by having multiple pipelines. And that's what happens in the Quantel Editbox and the Henry. So instead of doing those sizing, warping, filtering, and all this sort of stuff as steps that happen after each other, they can all happen at the same time. More detailed guided tour of this in a moment when I move the camera around, but I can actually demonstrate this multi-pipeline approach by looking at some of the cards. So this is the card that does the sizing. So you can see here there's quite clearly 3 independent channels coming in, and that allows this to do the sizing much quicker than it would happen on the Quantel HAL. That's just the card to do the sizing. And you have a card to do the image filtering, which is all your anti-aliasing and all that sort of stuff. So you can see there's 3 channels on here, and these cards work in parallel. So it's quite clear how much more processing power this has. It was a really big step up. Right, what are the other differences? We also, in this machine, we have 2 CPU cards. So that's one of the CPU 42 cards, 68040 CPU on there, running at 30 megahertz, 33, I think, something like that. 64 meg of RAM, etc, etc. But you have 2. So one does most of the tasks, and the other one sort of helps out when it's needed. One other difference with this over the HAL is the audio is recorded on a separate disc. On the Quantel HAL, the audio is recorded onto the system disc as an actual audio file, whereas on the Editbox and Henry, it has its own dedicated disc, which is accessed directly through hardware. So this is the card that does all of the audio and talking to the audio hard disk. The other difference with this over the HAL again is the DL and disk array. If you remember my HAL when I was working on that, trying to get the DL and disk array working, it has a separate box with 20 hard disks in it. It plugs into the HAL and provides all the video storage. Now, one thing that's different about this machine is we have an internal DL. So we've got 6 hard disks in here. Let's just pop this out. Probably can't quite see yet, but there's 2 cards with 3 hard disks on each, and these provide all the video disk storage. And there's only 6 disks, unlike the 20 that you saw in the DL. So a big step change there. When you have discs like this in this machine, it's called a buddy, I believe. So it's called a buddy disk array instead of a DL. Okay, the next step, what I'm going to do is reposition the camera. I'll give you a bit more of a tour around the machine, show you the significant parts of it, and what we're going to do is power this on and see what happens. We won't have all the cards in when I turn it on. In fact, I will probably disconnect most of the things that are in this off the power supply, just so I can power it up, check the power supply is okay, and then I can start plugging things in and seeing what's broken or not broken. So I've just rearranged the camera so you can see a little bit more of what's going on. You can see the size of this crate. It's 8U high, so it's a very big unit, and yeah, it weighs getting on for 60 kilos, I think, so it's not light at all. So in the top we have a large power supply. This is an Aztec MVP series, and these were used in all of the edit boxes and Henrys I have seen so far. So they obviously just standardised on this one. So the power supply is rated 5 volts, 120 amps, 12 volts, 30 amps, 5.2 volts, 9.6 amps, and 3.3 volts at 10 amps. So that sits there with some rather large bus connections onto the back plane, which sits in the back down there, and then all the other power connections sort of connect onto connections just in here. We've got a load of fans in the front just to push air over the whole thing. Then in the back we have this small daughter board. This plugs into the back plane as well, and this is all the video inputs and outputs. So in terms of the actual videos in ins and outs, we have analog video and we have SDI digital. So there are 3 SDI input channels and 4 SDI output channels. And you can configure these in various ways to get various different things on different screens. Also in the top here we have the hard disks. Now this is actually disconnected at the moment because the first thing I do when I get a machine like this is take the hard disks out and get an image of them, because I think it's important from a historical point of view just to try and get the data off them and get it recorded. Once you've done that, it doesn't matter if the disk fails, you've still got the data. So it's one of my first jobs that I do. So these have been imaged. So we've got 3 Fujitsu disks on here. They're all the same size and they were 18 gigabytes each. So this disc is the audio disc. We've got the shared disk and the system disk underneath. Now I was able to get full images of both the system disk and the audio disk, but the system disk has started to die, so I've only got a few hundred megabytes off it, unfortunately. So yeah, whatever was on that is now gone. Let's have a look at some of the cards in a little bit more detail. Now you have seen these cards before. A few years ago I did make a video on a Quantel Henry Infinity, which is almost identical to this. The only difference is it has a thing called Clipnet, which is a high-speed networking interface, so you can actually stream video on and off the DIL and disk array to another machine. It means you can have 2 machines that just share the video data between them, and you don't have to sort of send anything anyway. You can just do it all over the network. But this doesn't have that. It's just a standard DIL in isolation. So I will quickly run through these because you have largely seen them before. So CPU card, CPU 42, or is it a 43? Yeah, this is a CPU 43, slightly newer design than you might have seen. Specifically, it has the nice replaceable batteries on the non-volatile RAM. So 68040 CPU and 64 megs of RAM. Is doubled up on the second card. So exactly the same. Now the way that Quantel made these work together is quite clever. They both boot different versions of the operating system. So one knows that it's card 1 and one knows it's card 2. They both boot up and then they create a high-speed link between the 2 cards, and then they become synchronized. So it's a bit of a convoluted way of doing it because the 68040, I don't think it really supported multiprocessor, as in a true multiprocessor setup. Next card down is Netcom. So this provides all the PitchNet interfacing. So once you connect these into your normal network, Quantel machines will just pop up and see each other, and then you can access the shared files that are on each machine. So it's just entirely separate CPU on here, its own non-volatile RAM, clock, This is a 68349, and I think that is pretty similar to a 68020. That's running at 25 megahertz. So yeah, not a bad card in itself. So this is input select. So this does the analog video and it also selects between the digital video channels coming in from that daughter board that you saw up at the top. So it just allows the machine to switch between all the different video inputs. Next one down is Rave. So this is the audio processing card. So yeah, we've got some fairly chunky FPGAs on there. So this has to do all of the audio processing, and that can be you can have 4 native channels in the video, but then you can, while you're actually editing, you can actually have a background track and things like that, and you can also have a control surface with flying faders. So I would imagine this probably also does handle some of the interaction with the control panel, which has all the faders on that you can do. So that's the audio. Perspective, this is a fairly ordinary card actually. You see these in the regular Quantel paint box. So that just does perspective skewing and things like that. This is here more for compatibility with the paint box functions which are in this. So the Editbox and Henry can switch between an editing mode and a paint box mode. When you're doing video effects which need perspective, that will be done on these cards in here, not on here. If you're in paintbox mode and you're doing a perspective effect on a static image, it'll be using this one. So one of the store cards, this is Disk Store. Fairly, to me, it's fairly common, but yeah, it's just got plenty of RAM on. I think this should have Disk Store. I think 24 megabytes rings a bell. And the main store card, this will be the same as a Paintbox Express machine, so that should also be 24 megabytes. And last card on this side is the output select. So this is all the video outputs. You can see the analog video output modules there, and the rest of it's all the digital side. So this switches all the different video channels in and out depending on where you want them to go. We have this card called Display. So I'm not entirely sure what this actually does. I might have to do a bit of investigation and teach myself what the display board actually does. The next card along, so from address, size, filter, vidproc2 and key 2, these 5 cards, these are what make an Editbox and a Henry really as powerful as they are. So it's mostly handled by the address card. So the address card will take commands from the software and then program these 4 other cards to do all the stuff that they need to do. So all the compositing, the warping, the effects and all that sort of stuff. It all gets fed into these cards. So let's have a quick look at the address card. So yeah, there's quite a bit going on there. We've got an InMOS transputer. There's a rather large Shark DSP from Analog Devices. Lots of FPGAs, CPLDs. We've got some buffer RAM. Yeah, there's a lot going on. Some Raytheon chips. These will be either filters or what I stupidly call bit twiddlers. So they just do lots of maths basically. Card I showed you before, this is the size card. So you can see we've got 3 channels. So it can process all the luminance and chrominance just in one complete pass. And it does look like there's some SRAM on here as well, so that'll be high-speed static RAM, probably acting as a sort of a workspace for it. And we've got a similar situation here on the filtering card. So this does all of the image filtering, so it stops all the anti-aliasing. Now this is one of the cards where it's getting, you can see a bit of corrosion and stuff going on around here, so that does not look very good. And again, you can definitely see some grunge going on, so that will all have to be cleaned up, and we'll see what condition it's in. And unfortunately, this is one of the cards which is unique to the Editbox and the Henry. The next two cards are actually the same, or should be the same, as what you find in a Quantel HAL Express. So if you remember me talking about the HAL Express, that it used some of the cards from the Henry to make it faster, but it wasn't as fast as a Henry. You have seen that one before when we looked at my Quantel HAL. And again, the key 2. So this is all the keying, compositing. You can see 2 channels on there. Right, we have an empty slot here, and that's where Clipnet would sit. So Clipnet would be in there, and likely these 2 cards would be replaced with ones that are compatible with Clipnet. So, but the ones that would be in there would be doing the same job as this. So the first card here, if I just eject it out, there's not a lot on here. So this is disk convert. So this will be converting the video data into the data that is actually going to get written onto the disk. So this is effectively, this is like the control boards that were in the DL disk array, I think. Point out the size of the connectors on here. There's quite a lot of connections on there. This card, which is a bit of a beast. Again, these 2 cards are going to be effectively simulating a Quantel DL, but it's all just been compacted down now into one single card that can operate 6 disks instead of 20. Now you can see here there's definitely some more corrosion going on, a bit better. So there's definitely some corrosion on the top of those Altera Flex ICs. There's a lot of dust. So yeah, I can only hope this has survived the dust and the damp. If I just remove one of the disc packs. So we have 3, what size are these? I think these are 18 gigabytes. You can see also they are just as grimy. Oh, there's a dead spider there. Just as grimy as everything else. But yeah, they're 3.5 inch half height drives, which you don't see very often. So yeah, mounted on a rather substantial PCB, and big supports of aluminium to stop any flexing, because this is quite heavy. So we're over at the front. You can see the MO drive there. That is a 5.2 gigabyte version. So yeah, we'll see if that's still working. And I can just remove, because I've taken the screws off this already, the cover where we have all the cooling fans, which look particularly grimy. Yeah, it's definitely a bit horrible in there, and it's all that dust that just seems to stick to everything. The other issue as well, the fan shrouds have started to corrode, so all the dust is just sticking to the corrosion. So yeah, that's going to take some cleaning. So I'm just getting ready to power this on. All the cards are ejected. MO drive is disconnected. Drives are disconnected. So that is now disconnected also. So that should be it. I've got it connected up through my power meter so I can see how much power it's drawing, and I've got a breaker there as well. So oh, and it's on an RCD. What we're going to do is just plug this in the back and find where it goes. There we are. Right. So it's currently, that's off. So if I turn my breaker on, I should get nothing. What's that in watts? I'm getting 1 watt. Okay, that's not too bad. What I'm looking for here is the condition of the mains filter. These often have those XY caps that tend to explode. So you can normally detect them by how much they're drawing in terms of how much wattage or amps they're drawing. Now they always do have a little bit of natural leakage, but yeah, you sometimes start to see them go up, and that's when they're starting to fail, and then they suddenly just burst into flames. Yeah, that doesn't seem to be going up. It's fairly stable, so I think we're safe. That's fine. So let's switch that back off. What we'll do now is power the machine on, and then I'll just turn it on with the breaker. Alright, well, here we go. No. There was a click from the power supply, so I think something's just died. No, power supply's not starting up, so that's the first fault we're going to have to contend with. Right, what I'm going to do here, I'm going to conclude this video. What I want to do is get it edited, get it uploaded so you can actually start watching it. In the meantime, I'm going to figure out what we're going to do with the power supply. I do have a spare, which I think works, but it's going to be a bit of a task to swap that out. Thank you very, very much for watching, everybody. I hope you enjoy this one. If you did, give it a thumbs up, all that sort of stuff. I always welcome comments down in the comments section. As always, thanks to my loyal patrons and PCBWay. Thanks for watching, everyone. See you on the next video. Bye for now.